ಅವಳು ಬರಲಿಲ್ವಾ? Good evening to you all. We'll go with first question worksheet today. First question. In figure, O is the center of the circle. Get the figure, please. Draw a circle using a pass or any circular object. And PQ is a tangent to it. Ln is the diameter. Get the figure. And draw from the center to the point of contact. It is given O is the center of the circle, Ln is a diameter, PQ is a tangent to the circle at K, KLN is 30 degree. Find angle PKL. Find angle PKL. Is clear? So now from this figure we can guess OL and OK are equal. Can we say OL and OK are equal? Yes. Why OL equals OK? They are the radii of the circle. When they are equal, their base angles will be equal. Write the answer under the heading solution. In figure, OL equals OK, radii of a circle. Therefore, angle OLK equals angle OKL. Angles opposite to equal sides. Angles opposite to equal sides. So, this is 30. Therefore, angle OKL is also 30 degree. Now, can you guess the measure of LKP then? What is the measure of angle LKP? Can you guess? After knowing angle OKL 30 degree, what about the measure of angle LKP? No? Nobody could guess. Just apply the yes, it is 60 degree. We shall write. Why it is 60 degree? OK is perpendicular to PQ. Theorem 10.1. The radius drawn from the center is perpendicular to the tangent at the point of contact. So when OK is perpendicular to PK, this whole angle will be 90. Therefore, angle LKP equals 90 degree minus angle OKL. 90 degree minus 30 degree equals 60 degree. Is this clear? How it is 60 degree? Once again I will inform. Here, this is the diameter. OK and OL are the radius. So when the sides are equal, the base angles are equal. So angle OKL will become 30 degree. Now, OK is perpendicular to PK according to theorem 10.1. So the total angle is 90 degree. This is 30. 90 minus 30. LKP is 60 degree. The alternate way is we can use angles in the alternate segment also. But now it is very clear we can use the diameter part. We can also go with the theorem 10.1 condition. So it's better you can go ahead with this time. Okay, na? Is it clear to everybody? Question number 2. Is it clear? Okay. Next question. Very important question. It is from the textbook part. It is in the textbook example question. In figure, two tangents TP and TQ are drawn to a circle with center O from an external point P. Prove that angle PTQ equals 2 times angle OPQ. Most repeated question, very important question. Shall I move on to this figure? Take the figure, we'll have the explanation. Textbook example question, and based on this relation you may get the question as an MCQ also. So instead of right side tangent, I am taking this like this. We have to prove angle PTQ equals 2 times angle OPQ. So the relation is satisfied. So based on this you will get as 1 mark question. If angle PTQ equals 40 degree, what is the measure of angle OPQ? Then we say that it is half of, so it is 20 degree. When it is OPQ is given, we can write PTQ measure as double of the angle. So that is the result, and relation is satisfied all time. So I will go with this proof. Here in this question, we are using both the theorem concept. One theorem regarding theorem 10.1 The perpendicular, that is the radius drawn from the center is perpendicular to the point of contact. Second theorem is tangents from external point to a circle are equal in length. Okay, so just listen and observe. Later I'll give the time to copy. Very important question for 3 marks. Most repeated question. Okay, given. What is given you can write. What is given? TP and TQ are tangents. Tangents from external point T to a circle C O comma R, to a circle C O R, circle with center O, radius R. To prove angle PTQ equals 2 times angle OPQ. Proof. TP equals TQ. Why TP equals TQ? According to theorem 10.2, they are the pair of tangents from an external point. When TP equals TQ, these two angles are equal, right? That is angle TPQ equals angle TQP. Write the reason. Angles opposite to equal sides. Angles opposite to equal sides. So after getting these two, now let us have the angle sum property, which implies angle PTQ equals 180 degree minus 2 of angle TPQ. Angle sum property. I didn't showing taking all the 3 angles then subtracting. Directly I took these two are equal. So sum of these 3 angle is 180. This angle can be taken as 180 minus these two. Since they are equal, so I have taken 2 times angle TPQ. Is it clear? Now again, OP is perpendicular to TP. Reason? Theorem 10.1. OP is perpendicular to TP. That is, radius from the center is perpendicular to the point of contact. Point of contact means where the tangent touches the circle. So we can write sum of these two angles equal to 180 degree and 90 degree, which implies angle OPQ plus angle TPQ equals 90 degree. So to get the result, into 2, if you do 2 of angle OPQ equals 180 degree minus angle 2 of angle TPQ. I transfer after multiplying to get the result. 180 minus 2 of 2PQ, 180 minus 2 of TP. That means RHS of equation 1 and equation 2 are equal. To get the result, here I multiplied LHS and RHS by 2. 2 into this equals 90 minus this. I could have taken this equals 90 minus TPQ. Later into 2 also we can do. Now you write from the result 1 and 2. What we get? their LHS are equal. See the LHS. Angle PTQ equals 2 times angle OPQ. This is the result we require, hence true. Clear? Here we are applied two properties, theorem 10.1 property and theorem 10.2. Just to see and then check it down. Clear? In the first step, we have taken they are the pair of tangents. When they are pair of tangents, their base angles are equal. Then applying angle sum property, one of the angle at this point is 180 minus 2 of this. Second condition, we applied theorem 10.1. So since it is 90 degree, part by part together it is 90, multiplying it by 2, showing the RHS of both the conditions are same, so that we could equate their LHS form. That completes the proof. It's very important because it has the application of both theorem 10.1 and 10.2 problems. Next question. Question number 3. Here also PA and PB are tangents from point P. AB is a chord to the circle and O is the center of the circle. If angle OBA equals 10 degree, find the measure of BPA. Get the question. Question is in your worksheet. Get the figure. Without figure, don't answer. Figure itself gives the clear picture of the steps involved. To the center of the circle, it is joined. Okay. Now we have PA, PB, and this measures 110 degree. What is the measure of angle BPA? Here we should apply the property, the angle bounded between the tangents at the center and the angle at the tangents bounded by the external point and angle at the center to the point of contact is supplementary. Now just to see how I am explaining. So here OBA is 10 degree. What is the measure of OAB? 10 degree, because OA and OB are radii of the circle. When these two are 10 and 10, 180 minus 20, you will get, it is, what you will get? 180 minus 20, 160. And sum of the angles bounded between these two is supplementary. So when it is 160, this will be 20 degree. This is one way. Or if it is perpendicular 10 degree, then this will be 80. These two are pair of tangents. This is 80, this is 80. 80 plus 80, 160. 180 minus 160, 20. In both the way we can answer. Is clear? Very good, Vishal. Very smart in geometry part. Come on. Write the answer under the heading solution. This is 1 mark or 2 marks question. Solution. OA equals OB, radii of a circle, which implies angle OAB equals angle OBA. Angles opposite to equal sides. Therefore, angle OAB equals 10 degree. In the bracket you write, since angle OBA equals 10 degree. After showing each 10 degree, now apply angle sum property. Therefore, angle AOB equals 180 degree minus 10 degree plus 10 degree. Not much deep with the answer. This is highlight is enough. You will get angle AOB equals 160 degree. I think in the yesterday class only we have done it is cyclic quadrilateral. With that only we can prove when OA and OB are perpendicular, both 90 plus 90, the sum of the other two angles will be together supplementary, and we are going to prove it also later. Now after getting AOB, then you write, but angle AOB plus angle APB equals 180 degree. That is sum of opposite angles bounded between the tangents and radius at the center. At the center is supplementary. Sum of the two angles bounded is supplementary. So AOB is 160 degree. APB we have to find it out. So the measure of angle APB equals 120 degree. I'm sorry, 20 degree. Okay. Is it clear to everybody? So wherever we go, we are applying either angle sum property or theorem 10.1 property, 10.2 property, or the property what we studied in 9th standard regarding perpendicular distance bisects the chord, equal chords subtend equal angles at the center. So you have to recall all those properties what you have studied in 9th standard also. Clear? Next question. This type of question we already done. Anyhow, we'll do it. They have given the radius of the two concentric circles. We have to find out length of the chord of the larger circle. Just go back. Yesterday I have done this. Question number 4 in your notes. Yesterday's work. Have you done? Finding the length of the chord. First day class, just see. Yes, question number 4 from the worksheet is already done. I will move on to next question. It is bisected at the point of contact. Even this also we have done. Show that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. We have done. 6th question also we did yesterday. I hope. Is it clear? Now coming to the 7th question. 7th question. Get the figure. A circle. A circle is inscribed in a triangle. So we call it as incircle. Circumscribed a triangle, then it is called as circumcircle. Do you know that when you will get the circumcircle and on what condition you will get incircle? Any idea? How can we get the circumcircle and how will you get the incircle? How will you get? How will you get the circumcircle? No. Any idea? We have two types of circle, circumcircle and incircle. On what condition you will get circumcircle and what condition you will get incircle? I think in 9th standard for the old student I had discussed this. Incircle, circumcircle. Any idea? Otherwise you say no, then I will explain it. One more clue I will give up. For the circumcircle we require circumcenter. For incircle we require incenter. Any idea? Incenter, circumcenter, orthocenter, median. These are all point of intersection. Left is circumcircle, right one is incircle. I didn't ask to identify. I am asking how will you get circumcircle and incircle. It's apart from the syllabus. Anyway, knowing concept is not bad. We can think of it. I will show you how to do this also one day. Don't know? Okay. We get circumcircle to a triangle when we draw the perpendicular bisector to any of the two sides of the triangle. This point is called circumcircle. Using this center OA or OB or OC as radius, if you draw, you will get a circumcircle. That is, by the point of intersection of the perpendicular bisector, you will get circumcircle, circumcenter, and the radius we call it as circumradius. Now any guess for the incircle? For the incircle, how will you get? By constructing angle bisector to any two of its sides. Angle bisectors. This point is called in center. If you draw a perpendicular and taking this radius as in radius, if you draw, you will get a circle in circle which is a triangle. Okay? In center is the point of intersection of the angle bisector. Circumcenter is the point of intersection of the perpendicular bisector. This is circumradius. This is in radius. You may get the question based on this as MCQ. Please note down. Now we will move on to the question. Get the circle inside the triangle. So what I will do is first circle, and based on this circle I am supposed to manage the triangle which is touching the circle in D, E and F point. The point of intersection is here D, and here we consider as E, and this is F. Is given the incircle of an isosceles triangle where AB equals AC touches the sides at point D, E and F. Prove that BD equals BC. That is, it is bisected at the point of contact. So the alternate way of asking the question is, prove that BC is bisected at the point of contact. Based on this, you have 4 marks question in the textbook also. That is the reason. Yes, they are the tangents. Vaishnav, you are right. AB, BC and AC are tangents. Based on that, we have the pair of tangents. Can you guess? These two are pair of tangents, these two are pair of tangents, and these two are pair of tangents. According to theorem 10.2, length of the tangents drawn from external point to a circle are equal in measure. Yes. Shall we start? This is just 2 marks question. We'll start with the heading solution. Solution. Here you write length of the tangents. Length of the tangents drawn from an external point to a circle are equal in length, or equal because I started equal length in the beginning. So using this statement, we have the pair of tangents. They are AF equals AE, result 1, tangents from A. BF equals BD, result to tangents from B. CE equals CD tangents from C. Okay, this is the key answer we require to show BD is equal to CD, that is, it is bisected at the point of contact. Now just see the second part of this problem. Don't write, just see second part. Apart from the points what we get according to the theorem, we have extracted as result 1, 2 and 3. Now in the question it is given AB equals AC. It is an isosceles triangle. It is given AB equals AC. So we can write AB as, we can write AF plus BF equals AE plus CE. But AF equals AE according to result 1. I will cancel this from the result 1. What you will get? BF equals CE. But BF equals BD and CE equals CD. Bracket from the result 2 and 3. Is it clear? So when BD is equal to CD, what we can write? Therefore, it is bisected at the point of contact. Yes, bisected at the point of contact. Hence, proved. So, after getting the pair of tangents as result 1, 2 and 3, again using the condition given in the question, writing it as part by part, cancelling the equal according to the result 1, substituting the result left with the result 2 and 3. Finally, we got BD is equal to CD. That shows that BC is bisected at the point of contact. Here the point of contact of the tangent is D, hence the result. Okay. Is this clear to everybody? Okay. Now I will proceed to the next question. I will take the question figure in a vertical manner. It is easier for me to show the result. Okay. So take according to the figure what I am going to draw it on the board. Get the circle of any radius. They are given the length of the tangent. We have to find out the perimeter of the triangle. given here. This is P, C, D, A, B and E. AP equals 16 centimeter. Perimeter of triangle PCD is question mark. Perimeter of triangle PCD. Here also the problem in the worksheet, it is clipping figure. I made it as a vertical so that we can easily identify the pair of tangent instead of turning off the page. I cannot rotate my board, so I rotate the figure itself. Here A is given there. Yes, okay. A, B. Not visible, sorry, I didn't turn. Is clear now? Clear now? Okay. Now, here the length of one of the tangent, it is given PA 16 centimeter. We have three pairs of tangents in the figure. Which are the three pairs of tangents? Come on. One pair of tangent. Which are the three pair of tangents here? PA equals PB, CA equals CE and DB equals D. Okay na? Yes. PA equals PB. Result 1. Tangents from point P. According to theorem 10.2, yes, PA equals PB, then CA equals CE, result 2, tangents from point C, then DB equals DE, result 3, tangents from point D. Okay. Now see the procedure after taking three necessary results from theorem 10.2. Now we go with perimeter, not first row, perimeter of triangle PCD equals PC plus CD plus PD. sum of the three sides. Okay now? Next, P of triangle PCD equals PC. We can write CD as, how can you write CD? CE plus CA. I'm sorry. CE plus ED. How can you write PD? As it is. There is no change. Next line. Perimeter of triangle PCD equals, what is C according to the result? 2 CA. What is ED according to result 3? It is DB plus PD. In the bracket you write result 2 and result 3. Clear? I substituted CE as CA, DE as DB. Clear? So now, can you see? Next step, perimeter of triangle PCD equals, what is PC plus CA? PC plus CA is PA. Again, DB plus PD is PD. Right? Next, therefore, perimeter of triangle PCD equals PA equals PB according to the result 1. So we can write it as 2PA. From the bracket, we write by reason from the result 1. Now, perimeter of triangle PCD equals, what is PA given? 16. Therefore, perimeter of triangle PCD equals 32 centimeter. This is the relation. Is always constant relation. Okay. If you know the tangent length, we can find out the perimeter. If you know the perimeter, half of the length of the tangent. This is how we can relate the tangent from external point with respect to the perimeter drawn to it. Is clear? I hope that you all clear with this concept. Okay? Is clear? Shall I move on to the next question? Question number 9. Yesterday we proved when a quadrilateral is circumscribed by a circle, sum of the opposite sides is equal. Based on the property, we can find out the unknown part AD. If it is for 3 marks, we have to show how AB plus CD equals BC plus AD. We have done in the yesterday's class. But here they are asking only the length of AD as an MCQ question. Then directly we can apply when a quadrilateral is circumscribed by a circle. Then when a circle is circumscribed by a quadrilateral, then the sum of the opposite sides is equal. So can you tell me the answer directly? AB 6, BC 7, CD 4. What is the length of AD? What is the length of AD? Yes. What is the measure of AD? AB is 6, CD is 4, 6 plus 4, 10 equals BC is 7, 10 minus 7, you will get CD, AD as 3 centimeter. We had done this yesterday's class only, the relation where a circle touches all the four sides of a quadrilateral, that is nothing but a circle is circumscribed by a quadrilateral, then sum of the opposite sides are equal. Yes, come on, get the figure and mention the property, if not the proof, and keep in mind when it is for 4 marks we have to show how AB plus BC equals AD plus CD. Otherwise, directly you can mention the property. It is a circle circumscribed by a quadrilateral, their point of intersection in 4 distinct points. It's not going my order. When it is touching the 4 sides, they all become the tangents, and we know that the sum of the opposite side is equal, where AB is 6 centimeter, CD 4 centimeter, BC is 7 centimeter, AD question mark. It's clear, students? That is, when it is for 3 marks, we need the proof how we got. Now just mentioning the property, we can proceed. That is, if a circle is circumscribed by a quadrilateral, then AB plus CD equals AD plus BC. You can write the in bracket, refer previous page. Can you see now? Now is that okay? Okay, now write AB is 6 centimeter, plus 4 centimeter, 7 centimeter plus, AD plus 7 centimeter. 10 minus 7 equals AD. Therefore, AD equals 3 centimeter. Clear? In the 10th question, it's not angle TPQ, it is angle TRQ. Do the correction. TPQ is given, so we have to find out TRQ. So get the correction in your worksheet and now take the figure. I think this question I already discussed. Get the figure. They are the pair of tangents PT and Q. R is a point on the circumference of a circle with center O is 70 degree. Join this. Now I think it is clear how to get what is the measure of this. Is clear? Angle TPQ is 70 degree. Angle TPQ plus angle TOQ equals 180 degree. Are you agree? Angle TPQ plus angle TOQ equals 180 degree. Sum of the angles bounded between the tangent from external point and the radius drawn to the point of contact is always supplementary. Is it clear? Now TPQ is 70 degree, TOQ we have to find it out, where on subtraction you will get angle TOQ equals 110 degree. Now how to get angle TRQ? Any relation, do you know? What is the measure of angle TRQ? Angle TOQ equals 2 times angle TRQ. Reason? Angle TOQ equals 2 of angle TRQ. What is the reason? Central angle theorem. Angle some property now. Angle at the center. Yes, angle at the center is double the angle at the circumference. Therefore, 110 degree equals 2 into angle TRQ. Therefore, angle TRQ equals 55 degree. This is either 1 mark question or as 2 marks question. It's not C, it is TRQ. It's not 140 degree. Just to see the condition, angle at the center is not TPQ, it is TOQ. Therefore, angle TRQ equals half of 110 degree, it is 55 degree. Is it clear? See, after doing the 11th question, 12th question yesterday only we have done, 13th also we did yesterday, 14th just now only we have done the same type, and 15th also we have already done. So after doing the 11th question, that completes your worksheet, is it? Just go through that, you can answer. Now take the question number 11 figure. Question number 11. It is given perimeter of the triangle ABC is perimeter of the triangle ABC is 14 centimeter. Find AC. It is B, C, A, its center O. AB equals 5 centimeter. AQ equals 7 centimeter. CR equals 3 centimeter. And perimeter equals 14 centimeter. AC question mark. So they won't wait until I finish my writing. Their figure is not visible, left side is not possible, right side is not. One fine day they'll say you are not visible. Can you try? Can you try this answer? Right here, perimeter of triangle ABC. It is given perimeter of triangle ABC equals 14 centimeter. That is AB plus BC plus CA equals 14 centimeter. AB is given, and write first segment. BC can be taken as BP plus BQ, and CA, because they are asking CA only, you write. Okay. Here it is given AB 5, AQ 7. So BQ will be BQ equals AQ minus AB. That is 7 minus 5, it is 2 centimeter. When BQ is 2 centimeter, BP is also 2 centimeter, since BQ equals BP. This is also one more question. Logically you have to consider and write the answer. So BP is 2 centimeter, CR equals CP equals 3 centimeter. So we can get BC. And further, AB is 5 centimeter and BC as BP plus CP, it is 2 plus 3, 5 centimeter. AC together perimeter is 14 centimeter. So first we calculated this AQ minus AB, but BQ equals BP, they are the pair of tangent. Then CR equals CP, CR is given 3 centimeter, CP will be this. So 2 plus 3, 5 centimeter. Therefore AC equals 4 centimeter. Here also we applied theorem 10.2, length of the tangents from external point to a circle are equal in measure. Is it clear? You want this explanation again? Here it is given AQ, subtract AB, you will get BQ, where BQ equals equals BP, they are the pair of tangents. So this will be 2. CR is 3 centimeters given. CR is equal to CP. It is 3. 3 plus 2, 5. Already 5 is 5. Adding, subtracting from total perimeter, you will get the length AC as 4 centimeter. Is it clear to everybody? Is it clear? No answer, no response. Okay. Now listen, question number 12, yesterday only I did. Okay. Question number 4 also we have done in the yesterday's class. Question number 14, like sum of the opposite sides of a quadrilateral circumscribed by a circle is equal. So 6 plus 9, 15 equals 8 plus AD. So AD equals 15 minus 8, it is 7 centimeter. Like previous two, before the two problems, we have done the condition sum of the opposite sides are equal. Using that, you can find the length of AD. Now, the length of the tangent, this type question also we have done. Here we have to find the radius. I'll give the figure. This is the figure for the question 15. The length of the tangent from a point A at a distance 5 centimeter from the center of the circle is 4 centimeter. What is the radius of the circle? This is how we get the figure. Here OA is perpendicular, therefore OP is perpendicular to AP according to theorem 10.1. So you will get a right triangle where square on the hypotenuse equals sum of the squares of other two sides. OA is 5 square, OP is, we have to find out the radius, and it is 4 square. R equals root of 25 minus 16 root 9. So the radius is 3 centimeter. Huh? Last one? We have done. Okay, so that completes your worksheet. We'll continue with few more questions in the next class. Okay, practice the theorems and apply the theorem property for answering this. We have 4 marks question also in the textbook. We'll do that discussion in tomorrow's class. Okay children, is it clear to everybody? Okay.